Hello students, let us start our new session of chapter 12, atoms. Now let us start with the new topic, alpha particle trajectory. Here this trajectory traced by the alpha particles depends on the impact parameter. This impact parameter is known as a B, as you can see in the diagram, that is of the collision. So this impact parameter is perpendicular distance of the initial vector of alpha particle from the center of nucleus. Basically it gives you the perpendicular distance between the alpha particles and the scattering parameters. So here the beam is scattered in various directions with different probability. This alpha particle close to the nucleus, then it will suffer large scattering, and if alpha particle is available away from it, then scattering cannot be experienced. So here the impact parameter, if it is minimum, then alpha particle rebounds back, that it takes a backward path, which is known as head-on collision. I repeat, the impact parameter B is minimum, then alpha particle rebounds back by the theta equals to pi, which is known as head-on collision, and the alpha particles goes nearly undeviated, that very small deflection is available about 0, that if theta equals to 0, then it's known as large impact parameter B. So here when deflection is not there, impact parameter B is larger, and if theta would be pi, then that would be a small that impact parameter would be minimum, that is small value would be there. Here a small fraction of number of incident alpha particles will rebounce back, and which gives that the small number of alpha particles undergoing through head-on collision. So here the volume, that small volume which is concentrated at the center, which define the mass of the atom. So here by using that alpha scattering method, we can determine the size of the nucleus, that from that nucleus part, if alpha particle will rebounds back, then within that size defines the nucleus. Other than this size of nucleus, alpha particle won't deflect and it will move straight direction. Clear? Let us go through the example regarding the same. In the Rutherford's nuclear model of the atom, the nucleus having a radius 10 raised to minus 15 meter is analogous to the sun, about which the electron move in orbit. That orbital path is 10 raised to minus 10 meter, like the earth orbits around the sun. If the dimensions of the solar system had the same properties as those of the atom, would the earth be closer to or farther away from the sun? Then actually it is the radius of earth's orbit, that is 1.5 into 10 raised to 11 meter, and the radius of the sun is taken as 7 into 10 raised to 8 meter. So if we are taking the ratio of radius of electron's orbital path to the radius of nucleus, that is 10 raised to minus 10 to 10 raised to minus 15, that ratio is available 10 raised to 5. So that is the radius of electron's orbit, that is 10 raised to 5 times larger than nucleus. Now if we are analyzed based on the sun and its planets or orbital path. So let us take again the ratio of Earth's orbital path around the sun, which is 10 raised to 5 times larger than the radius of the sun. So by taking that ratio, that 10 raised to 5 into radius of sun, that is 7 into 10 raised to 8, then we will get the answer 7 into 10 raised to 13 meter, which is 100 times larger than the actual orbital path of the Earth. So we can say that Earth is much farther away from the sun. It defines that the atom contains a much greater empty space than the solar system. Next example. In a Jaeger-Marsden experiment, what is the distance of closest approach to the nucleus of a 7.7 mega electrovolt alpha particle before it comes momentarily to rest and reverses its direction? So here we need to define this closest distance, which gives the collision. So here we need to follow the scattering process in which the total mechanical energy of the system of an alpha particle and a gold, it should be conserved. So based on the conservation of a law of conservation of energy, we are taking a reference and we try to determine the distance. So initial mechanical energy, that is EI, before the particle and the nucleus interact, and that would be equal to its mechanical energy EF, the final mechanical energy when alpha particles momentarily stop. So initial energy EI, that is a kinetic energy that will be available with the alpha particle, and final energy that is available while the alpha particle becomes rest, it comes to momentarily at a rest condition. So at the rest condition, that particle having a potential energy, let us define as a U. So now let us take D is the distance between center to center between the alpha particle and gold nucleus and alpha particle where it stopped to move. So here, based on the conservation of energy, EI equal to EF. So here, kinetic energy, that is based on the given force, that work done equal to energy divided by distance. So kinetic energy, that is equal to work done, and force, that we are having Coulomb's force, divided by R, the distance. And that distance, one time it will be cancelled out. So instead of D square, now we are having distance D. So now we are having kinetic energy, that is 1 upon 4 pi epsilon 0 twice E, that is a helium charge, into ZE, that is a gold charge, divided by D. By solving it, we are having equation twice ZE square divided by 4 pi epsilon 0 D. Now from that equation, make the subject of formula D. So from that we are able to get the distance value D equal to twice Z square divided by 4 pi epsilon 0 K. Now it is already given the kinetic energy value, that is 7.7 mega electrovolt, or convert into joule. So we are having 1.2 into 10 raised to minus 12 joule. And we are having 1 upon 4 pi epsilon 0 constant, that is 9 into 10 raised to 9 Newton meter square per Coulomb square. And E, that we are having charge of particle 1.6 into 10 raised to minus 19 Coulomb. By substituting all the constant values, we are able to get D equal to 3.84 into 10 raised to minus 16 Zm. And Z, that is the atomic number of gold, that is a 79. So here, if we substitute it, so we are able to get D equal to 3 into 10 raised to minus 14 meter, or 30 femtometer. That femto, that is 10 raised to minus 15 meter. So here, the radius of the gold nucleus is less than 3 into 10 raised to minus 14 meter. So here This is not in a good agreement with observe that the result of actual radius of nucleus is 6 femtometer. So the cause of discrepancy is here defined that distance of closest approach is considerably larger than the sum of radii of golden nucleus and alpha particles. So that's why alpha particle reverses its motion without touching the gold nucleus. Now, let us discuss the next topic, electron orbits. Here the atom, which is electrically neutral, in which all the small that positively charged particles are concentrated at the center. This is surrounded by the orbital path, which is in circular path in which electrons are revolving. So here the electrostatic force of attraction Fe present between electrons which are revolving in orbital path and which is provided by the centripetal force to keep them maintained in its orbital path. So here this is dynamically stable orbit. If we are calculating for the hydrogen, that we can determine Fe equal to Fc. And Fe, that is mv square by r, that is electrostatic force, and Fe, that is a Fc, that is Fe based on the Coulomb's force, 1 upon 4 pi epsilon 0 E into E by r square. So by the Coulomb's law and the centripetal force, if we are equating and make the subject of formula R, so here we are able to get radius of orbit R equal to E square divided by 4 pi epsilon 0 mv square. Here K is the kinetic energy, and if we are define U, that is the electrostatic potential energy of the electron, then K equal to 1/2 mv square. So from the above equation, if we substitute mv square over here, so we able to get 1/2 mv square equal to E square by 8 pi epsilon 0 r, and potential energy that would be equal to minus E square by 4 pi epsilon 0 r. Here negative sign defined. The electrostatic potential is available at minus r distance. So total mechanical energy of electron in the hydrogen atom E equal to K plus U. Substitute the value of kinetic energy and potential energy, and we are able to get E equal to minus E square by 4 pi epsilon 0 r. And here the energy is negative, defines the energy of the electron. It defines that electron is bound to the nucleus. If E is positive, then electron will not follow that circular path. So here it defines that negative energy existed. It means electron is following its orbital path continuously, which gives the electron orbit. Let us go through the example regarding the same. It is found experimentally that 13.6 electrovolt energy is required to separate a hydrogen atom into a proton and an electron. Compute the orbital radius and the velocity of the electron in a hydrogen atom. So here hydrogen total energy is given minus 13.6 electrovolt. Convert into the joule by multiplying 1.6 into 10 raised to minus 19 joule. So the total value we are having, total energy of electron in hydrogen atom, that is minus 2.2 into 10 raised to minus 18 joule. And here we are having a total energy that is minus E square by 8 pi epsilon 0 r, which we have just observed earlier. That would be equal to minus 2.2 into 10 raised to minus 18 joule. From that, make the subject of formula R and substitute all the constant values. So we able to get radius equal to 5.3 into 10 raised to minus 11 meter. Now, if we want to calculate the velocity of electron which is revolving in this radius of orbital path, having m equal to 9.1 into 10 raised to minus 31 kilogram, which is the mass of electron. So, in the equation mv square by r, make the subject of formula v and substitute these values, that v equal to E divided by under root of 4 pi epsilon 0 m into r. So by substituting all the values, we able to get velocity of electron, that is 2.2 into 10 raised to 6 meter per second. Clear? I hope you understood. Here we are going to end this session. Hope you understood. Thank you.